If you're losing points in algebra, it's probably not because you don't understand the concept. It's mostly because you're making one of these 10 mistakes. Let's fix them right now. Here's mistake number 1. Dropping negative signs. Students often drop the negative sign and therefore jump to incorrect operations. For instance, if you're trying to solve the equation negative 3x plus 5 equals 2, you'll subtract 5 from both sides to isolate x. But when rewriting the equation, instead of rewriting negative 3x, you rewrite 3x equals negative 3. That would be incorrect. So the correct way to do it, yes, you subtract 5 from both sides, but when rewriting the equation, negative 3x still remains negative 3x, and that would be equal to negative 3, and therefore you can solve for x. In this case, x is equal to 1. Negative signs are not decorations, so treat them like numbers. Mistake number 2 is distributing incorrectly. Distribution means multiplying everything inside the parentheses, not just the first term. This is one of the most common errors in algebra. For instance, if you multiply 3 times x plus 4, where x plus 4 is in parentheses, that is not equal to 3x plus 4, because in this case, only the first term was multiplied and the 4 was left untouched. 3 needs to be multiplied by both terms inside the parentheses. Therefore, 3 times x plus 4 is equal to 3x plus 12. Mistake number 3, combining unlike terms. 2x plus 3 is not equal to 5x, because you cannot combine x terms and constants. They are fundamentally different types of terms. In this case, the expression 2x plus 3 is already simplified. These terms cannot be combined further. Think of it this way. Apples plus oranges is not equal to apples. Variables and constants are different fruits. So you can only combine terms that share the same variable and exponent. Mistake number 4 is squaring binomials incorrectly. This mistake trips up students constantly. Squaring a binomial is not the same as squaring each term individually. There's a critical middle term. For instance, if you're trying to do this operation, x plus 3 squared, this is not equal to x squared plus 9 because the middle term 2ab is completely missing. The correct way would be x squared plus 6x plus 9. You'll need to apply the full formula with all 3 terms. And here's the formula. A plus b squared is equal to a squared plus 2ab plus b squared. Always remember the 2ab middle term. Mistake number 5, canceling terms incorrectly. X plus 2 over x is not equal to 2. Students often cancel the x from top and bottom, but you can't cancel terms, only factors. In this case, the expression x plus 2 over x cannot be simplified. The numerator is a sum, not a product. So remember, you can cancel factors, not terms. If it's connected by plus or minus, you can't cancel it. Mistake number 6 is a critical error, dividing by 0. When simplifying expressions, students often cancel factors and forget that the variable cannot equal the value that would make the denominator 0. For instance, if you have x squared minus 4 over x minus 2, yes, that simplifies to x plus 2. But what students forget is that there's a restriction here. X cannot be equal to 2, because in this case, the denominator would be 0. So always state restrictions. Before you cancel, ask yourself, what value would make the denominator 0? And then exclude it. Mistake number 7, forgetting to flip the inequality. When you multiply or divide both sides of an inequality by a negative number, the inequality sign must flip direction. Forgetting this changes the entire solution. For instance, if we have negative 2x is greater than 6 and we want to solve for x, yes, you divide both sides by negative 2, but you need to flip the sign. So x is not greater than -3. In this case, x would be less than -3. So here's the tip. Multiply or dividing by a negative, flip the sign. Every single time, no exceptions. Mistake number 8. Exponent rules confusion. Students frequently mix up when to add exponents versus when to multiply them. The power of a power rule requires multiplication, not addition. So if we have x cubed raised to the second power, or x cubed squared, that is not equal to x to the power 5. In this case, that rule applies to multiplication of like bases, not power of a power. So if you have a power of a power, you will multiply the exponents. So x cubed squared, will be equal to x to the power 6. So here's your memory tip. Power of a power, multiply exponents. Same base multiplied, you will add exponents. And you can check my lesson on exponents. You can find a link in the top corner here. Mistake number 9. Misusing absolute value. Absolute value measures distance from 0, which means there are always two possible solutions, one positive and one negative. So if the absolute value of x is 5, x is equal to 5, yes, but that's only one solution, the positive case. Both the positive and negative solutions should be included. So x could be equal to 5 or x could be equal to -5. So always write both solutions of absolute value. And finally, mistake number 10. Don't skip this one. Not checking solutions. Students sometimes solve equations and forget to check for extraneous solutions. That is, answers that emerge from the algebra but don't actually satisfy the original equation. For instance, if you're trying to solve the square root of x plus 1 plus 4 is equal to x minus 3. Solving this may produce values that are invalid when plugged back into the original equation. So always plug answers back in. If the original equation breaks, that is division by 0 or negative under a square root, that solution is extraneous. So throw it out. Here are the 3 habits that prevent all 10 mistakes. Slow down, show every step, and then check your work. Most algebra errors aren't about understanding, they're about carelessness. Building these 3 habits will eliminate the vast majority of lost points on tests and homework. So fix these 10 mistakes and your math grade changes immediately. Which mistake have you made before? Please comment the number below. Thanks for watching. Please like and subscribe to keep learning from us. And don't forget, math success starts when you stay on the fast track.